Hello learners, welcome to Dr. D.Y. Patil Vidyapeeth's Center for Online Learning. I am Professor Dattatray Katore and you are studying with me statistics and quantitative techniques. In this video, we are going to study game theory, which is unit 13 of your course Statistics and Quantitative Techniques. So what exactly is game theory? It uses mathematical tool to study situations which are called as games involving both conflict and cooperation. So there are two types of games, conflicting games and cooperative games. So there are many business situations where more than two or more parties have conflicting interest. They have actions of one depends upon the actions of other, right? For example, business firms competing for higher market share. So these kind of business situations are there where where there are conflicting interest. Action of one is against the action of other. So such kind of situations are there, and business firms have to compete with each other. They have to contest a game with each other, and they have to win ultimately. So there are players, the people, organizations, or even countries in a game that choose from a list of options available to them. They are participant or players. So there are people, they can be organizations, or they can be even countries uh, that in a game that choose from a list of options available to them. So these organizations, people, and countries choose options available to them, various courses of actions available to them, and the choice of the course of action these organizations or players or people have chosen determine their success. Strategies: the courses of action they may take to lead to outcomes which describe the consequence of choice. So there are various courses of action that can be followed, right? So these courses of action are called as strategies, which describe the consequences of the choice made. A firm may reduce, the example is the firm may reduce price to increase the market share. The firm may increase the advertisement expenditure in order to increase the market share. So one can have multiple courses of action, and one has to choose the better course of action ultimately, which will determine the success of the player. Rational choice: strategies are analyzed in game theory and players select strategies to obtain preferred outcome. These are some terms involved in game theory. Then two-person games of total conflict. So games in which one player wins and the other player loses. If one player wins, other player loses. So cooperation never benefits the player. So these are conflicting games, right? Then pure strategy game, a course of action a player can choose in a game that does not involve randomized choices. A player always chooses a particular strategy. So before the play actually starts, the player decides in advance what strategy he will be playing in the game. So player always chooses a particular strategy. He has always decided what strategy he will be using before actually the play starts. Mixed strategy: decision of the player ahead of the play before the play is started, right? So decision of the play before the play is started to choose more than one strategies which have fixed strategies or probabilities. So in mixed strategies, players have to choose more than one strategy which have different probabilities. Then payoff. Payoff is the outcome of playing game, right? Output we can say. Then there is a payoff matrix. So payoff matrix is a rectangular array of numbers. In a two-person game, the rows and columns correspond to the strategies of two players, and numerical entities give the payoff to the players when these strategies are selected. So in front of you on the right hand side there is a payoff matrix. So this payoff matrix consists of arrays. All right, so we have player A, and as this is a conflicting game, player A is a maximizing player, we can say, who tries to maximize the profit, and there is a player B who is a minimization player, let's say. So player B tries to minimize the loss. So the values represented here, these are the outcomes, right? These are the payoffs: A11, A12, A13, then A21, A22 and A23. These are the payoffs. Payoffs means, outcome of playing game, right? So here A1, capital A1 and capital A2 are the two strategies available to player A. Then B1, B2, B3, these are the three strategies played by the player B. And these values A11 represent profit for player A, as A is a maximizing player, and the same value A11 represent the loss for player B if he chooses B1. Game theory: there is saddle point, the payoff that result when the maximin and minimax are same. So when we get a value where the maximin is equal to minimax, so let us understand. Okay, we will understand what is maximin and minimax shortly. So when maximin and minimax are same, we say that there is a saddle point, which is also the value of the game. The saddle point has the shape of saddle shaped surface. The middle point on a horse saddle is simultaneously the lowest point along the spine of the horse and highest point between the rider's legs. So therefore it is called a saddle point. Value: the best outcome that both players can guarantee in two-person zero-sum game. If there is a saddle point, this is the value. Otherwise, if the expected payoff resulting when the players choose their optimal mix strategies. So value is the outcome of the game, right? And saddle point is when maximin is equal to minimax, so we get a saddle point, and it is also the value of the game. So basically we come across two types of games here: two-person game with multi-person, or two-person game or multi-person game, then zero-person game versus zero-sum game versus non-zero-sum game. So we will understand these terms. What is maximin? So in a two-person zero-sum game, the pure strategy of the player, of the row player corresponding to the maximin in a payoff matrix. Maximin, the largest of minimum payoff in each row of the payoff matrix. So I will show you how to calculate, how to find out the maximin. Then there is minimax strategy. So in a two-person zero-sum game, the pure strategy of the column player represent the minimax in a payoff matrix. So the smallest of the minimum payoff in each column of a payoff matrix. Then mix strategy games. So a strategy that involves random choice of pure strategies according to particular probabilities. So mix strategies means player does not choose a single strategy while playing a game. Rather, he uses multiple strategies, more than one strategies, each with different probabilities. So such kind of game is called as mix strategy game. A mixed strategy of a player is optimal if it guarantees the value of the game. Alright, so players must take care to conceal the strategy they will select until the encounter actually takes place. So example is basketball. So in basketball, a pitcher may not signal the type of pitch she sends to throw in advance. So this is mixed strategy game. So the opponent player will not reveal his strategy until the play is started. The player plays different strategies, each with different probabilities. So player may also vary their strategies in order to surprise the opponent. Players may also use the tactics of bluffing, which involves secrecy and deception. Example, bluffing when playing a poker, right? So game theory: pure versus mixed strategy. So what is a pure strategy? Pure strategy game means a player chooses a particular strategy before the play is started. A mixed strategy in which the course of action is randomly chosen from one of the various strategies available to the player, right? So each pure strategy is assigned some probability indicating the relative frequency with which that pure strategy will be played. The specific strategy used in any given play of the game can be selected using some appropriate random device. Expected value: that is E, if each of n payoff S1, S2, Sn will occur with the probabilities, let's say P1, P2 up to Pn respectively, then the average or the expected value E is given by multiplication of probabilities and samples, addition of multiplication of probabilities and payoffs. Pair game. So what is a pair game? A game is pair if its value is equal to 0. Consequently, it favors neither player when at least one player uses an optimal strategy, one that guarantees that the resulting payoff is the best that this player can obtain against all possible strategies by the opponent. Then there are non-symmetric games. So what are non-symmetric games? A two-person constant sum game in which the row players gains are different from the column players gains except when there is a tie. Then there is a zero-sum game, a constant sum game in which payoff to one player is the negative of the payoff of the other. So the sum of the payoff of the game is 0. So payoffs are same with different signs. If one pair gets payoff of +1, other gets payoff of -1, then the sum of the game is 0, because +1 and -1 is equal to 0, and therefore this game can be called as a zero-sum game. So we have an example of game here. So let us try to solve this game. So first of all, we have to try to find out uh, you know uh, the saddle point. So how do we find out the saddle point? So basically we try to calculate maximin and minimax to solve the saddle point, to find out the saddle point. So what we do, we find out row minima. So let me take the pointer option. We find out row minima. So the minimum element in the first row is 2. Then the minimum element in the second row is 6. So we calculated the row minima. Now let us find out the column maxima. Now here you will understand how to calculate minimax and maximin. Now while finding out the column maxima, we have to choose the largest value in a column. So in the first column the largest value is 7, in the second column the largest value is 10, and in the third column the largest value is 6. Now we have to find out minimax. So what is minimax? So we have found out here the maximum values and we have to choose the minimum of them. So it is 6. So minimum of these three is 6, that is minimax. So minimum of these maximum values is minimax and it is 6 here. Let us now find out maximin. So we have already found the row minima. So we have to take the maximum value out of them. The maximum value of these two values is 6. So here the minimax and maximin are same. So minimax is equal to maximin is equal to 6. Therefore saddle point exists. So when minimax is equal to maximin, saddle point exists and it is the value of the game. So this is how we solve a game. Okay, so we have another game here. So here we try to solve it. Let us again find out the column maxima. So column maxima is 4 and 5 and minimax is 4. Let us find out row minima 3 and 1, and here maximin is 3. So minimax is not equal to maximin and therefore in this game we do not have a saddle point. So how do we solve this kind of game? So this game is not a pure strategy game, because we have to player chooses not a single strategy but the combination of two strategies in this case, each with different probabilities. So here we find out the value of the game. How do we find out? By using this particular equation we find it out. So we have to compare this particular table or this particular matrix with the initial table which we have seen. So let us say this is player A, and player A has two strategies, A1 and A2. Then there is player B. Player B plays two strategies, B1 and B2. Alright, so 3, 5. Let us write down these values: 3, 5, 4 and 1. So these are the payoffs. So this is nothing but A11, this is nothing but A12, then this is uh, A21, and this is A22. So now we have to compare this particular table with this formula. So we just have to put the values in this particular formula. We will get the value of the game. So A11 is 3 multiplied by A22 is 1 minus A21. A21 is 4 multiplied by A12. This is A12 actually. So A12 is 5. Again we have to take a denominator. So 3 plus 1 the same way minus 4 plus 5. So when we solve this, what do we get? 3 ones are 3, 4 5 are 20. So 3 minus 20 divided by 3 plus 1 is 4 and 4 plus 5 is 9. So 4 minus 9 is minus 5. So the value of the game is 17 divided by 5. So this is the value of the game. We can even calculate the probabilities also. So probability of playing the game, probability that the player A will choose the strategy A1 is P, and that he will choose the strategy A2 is 1 minus P. The player B chooses a strategy B1 is Q, and that he will choose the strategy B2 is 1 minus Q. So we can calculate the probabilities also. Yes. So that's all about the game theory. I hope you have understood what is game theory. Game theory has very wide applications in business situations. So thank you so much for watching this video. Keep watching videos.